Hi guys, today we're going to go ahead and make instant ice. And so in order to do this, we need a couple things. We need a small bag of ice, purified water, 16.9 ounces is what I used. It's very important that it be pure water. So store-bought water is best. We need a cup or a bowl and a freezer. Okay, so we're going to try to make instant ice 3 different ways. Okay, we have the first way is freeze the bottle with a smack. The second way is pour and freeze. And then the third way is called instant freeze in a cup. And in order to do all 3 of these, what you'd have to do is you first need to put your water bottles in the freezer for about 2 hours and 45 minutes, or until the water reaches a negative 24 degrees centigrade or a negative 11 degrees Fahrenheit. We're going to super cool that water. We're going to take the bottles out of the freezer. Hopefully they're still in a liquid state, but the temperature is still going to be below freezing. And then we're going to go ahead and run our experiment. And bang the bottle, we're going to go ahead and hit it on the counter. In our second one, we're going to pour our water over ice. And in the third one, we're going to go ahead and put it in a cup of water and then apply an ice cube to hopefully watch it freeze. So what do we know about water? Well, we know that water from 0 to 100 degrees is a liquid. Water boils at 100 degrees centigrade. That means that water undergoes a phase change from a liquid to a gas at that temperature. We know that water freezes at 0 degrees Celsius. It's 0 degrees Celsius is the freezing point or melting point of water, and it's the temperature at which water changes phase from a liquid to a solid or vice versa. And it's at the freezing point that water molecules have slowed down enough to develop bonds when they collide. So now instead of just colliding and bouncing back away from each other, they're going to collide and they're going to stick. They're going to form that bond, and they're going to form a crystal lattice, okay, which we know is ice. And so ice crystals, they start to form and they're going to grow in the water. And it's thought that these initial ice crystals often form around impurities in the water. So regular tap water has things like minerals in it, maybe some dust particles in it, that pure store-bought water, purified water does not have. So super cooling, is it magic or is it science? Well, liquids like water can be super cooled beyond their freezing point, so they don't solidify until well below the freezing point. Once the water molecules start to form bonds, they undergo a process called nucleation. And nucleation is the formation of small solids within the liquid. The nucleation sites become landing sites for other water molecules to attach to, and ice grows. So we have this nucleation point, and then we have a water molecule comes attaches to that, another water molecule attaches, and another, and we get our ice formation. So if you start with a sample of pure water and cool it slowly, we're going to make what's called a super cooled liquid water. Okay? And that's what we did when we put the water bottles in the freezer for 2 hours and 45 minutes. We lowered the temperature of water beyond the freezing point. Okay? So water needs a seed crystal or other small particle to that nucleus on which to form crystals. And in purified water, there are no seeds to kick off the process of freezing. The liquid exists in what's called a metastable state. And a metastable state is one in which the system has the lowest possible free energy. So it's just hanging out in liquid form. It doesn't want to undergo any phase changes. And so this is why in purified water, the freezing temperature is much lower than in non-purified water. Very pure water won't crystallize until the structure of liquid water molecules approaches that of solid ice or an impurity is introduced. Until then, there's no seeds to start the process of freezing, and the water is just super cooled. It's just hanging out in liquid form. Again, water needs a seed crystal or some other impurity on which to form crystals. So this is why water needs to be impure in order to form ice. While dust or impurities in water normally offer a nucleus on which to build ice crystals, very pure water, again, it won't crystallize because it doesn't have that impurity on which to build the ice. It's not going to freeze until liquid water molecules approach that of solid ice. It's the impurity in the liquid that stabilizes the small ice crystals as they form. And the water molecules will bind to the impurity and start a chain reaction as more and more molecules latch onto the growing mass of ice. And that's what triggers the transition from the liquid to the solid or water to ice. Okay, so let's find out what happened when I tried the 3 different ways in order to make ice. Here's the first way. Freeze the bottle with a smack. Hi guys, so today we're going to be looking at making instant ice, and we're going to be making ice 3 different ways. And so the first way we're going to make it is I'm going to go ahead and take my bottle of water. It's been in the cooler or the freezer for 2 hours and 45 minutes. So it's been changing into what's called a super cooled liquid. And so theoretically what should happen when I bang my bottle of water, you can see it's still liquid there. Okay, on the table it's supposed to instantly freeze. So let's go ahead and give this a try, shall we? Keeping my fingers crossed for this. There it goes. You see it's kind of going all the way down to the bottom. It's freezing from the top down to the bottom of the water bottle. That's the first one. Ooh, it's all this great slushy feeling ice in there too. That's gonna be nice to drink when that starts to thaw out a little bit. So let's go on to experiment number 2. Number 2 is called pour and freeze. So I went ahead and poured water over ice to watch the ice crystallization form, and we made pillars of ice as the water was poured. The next way I'm going to try to make instant ice is I'm going to take my liquid bottle of water. Remember, it's been super cooled, and I'm going to pour it onto my bowl of ice. And hopefully I'll get this nice ice pillar effect happening. Very careful. I'm opening it here. And here's my bowl. I'm going to take my water and hopefully, my instant ice. A nice ice pillar. Just keep going. I'm going to pour the whole thing out. Reach the top. Okay. Well, what happened there is I touched the very tip of my water bottle to my slushy ice pillar here, and it ended up backing up into my bottle, so it actually froze the very top of my water bottle. So that was the end of my ice pillar growing. But that was actually really cool. All right, get ready for experiment number 3. Number 3 was instant freeze in a cup. Hi guys, so we're ready for experiment number 3. So I have my super cooled water here, and what I'm going to attempt to do is I'm going to attempt to very carefully pour it into this container here, and then we're going to apply an ice cube to it and see if we can't get it to freeze. There's my super cold water. I'm getting an ice cube, just a regular old standard ice cube. I'm going to just barely touch the surface of this and see if it's going to freeze for me. I don't know if this one's successful. It looks like this particular experiment might be a bust. It's definitely getting cold. It's just not freezing. This could be maybe because when the tip of the bottle touched the rim of the glass, it started to freeze, and maybe when that happened, it spread to the rest of the water in the water bottle, and it kind of pre-froze it, and so the ice didn't have any effect on this particular experiment. Okay, so what happened in our experiments? So phase change requires both energy and some irregularity in order for the phase change to proceed. And so the water in our bottles, they're going to stay liquid until something kicks off that nucleation process. So during the smack, a smack given to the bottle is enough to start the formation of ice crystals. The energy from the smack catalyzes the formation of ice crystals by getting water molecules to line up in just a certain way and provides a spontaneous nucleation point, resulting in a homogeneous nucleization. And the water freezes. In the pour and freeze, when the water is poured out of the smooth container onto the rough surface of the ice of the bowl, it's jostled about as it splashes against the surface, and the shock waves crystallize the supercooled fluid. And in both the smack and the pour and freeze, as soon as that nucleation occurs, it provides that spot where water molecules can keep adding on, and then we get more and more ice formed. And the last one, the instant freeze in a cup, what is supposed to happen is when ice is added to the supercooled water, It's going to act to catalyze the crystallization of the liquid, and the ice is supposed to provide the nucleization point. This did not happen for me. I think what happened is I maybe touched the edge of the glass, and so the super cooled water solidified within my water bottle, and there was no way, the reaction had already occurred. There's nothing else left to take place. And so it just didn't work. In each instance, the impurity in the liquid stabilized the small crystals and they formed. I'd be interested to try that third experiment again on another day. Unfortunately, I had 2 other bottles of water in my freezer, and both of them froze before I could even take them out of the freezer.